Welcome to the second webinar on MySQL from JPassion.com. Today's topic is MySQL Basics II. Again, for those of you who have an access to JPassion.com, feel free to download the lab and you can actually do the lab exercises together with me. I'm going to actually demo most of the exercises. Okay, so let's move on with the presentation. So what we are going to cover today include field modifiers such as auto increment, index, and unique, and table modifiers. Last week there are a lot of questions in terms of InnoDB as a storage engine. So we're gonna take a look what kind of storage engines are supported by MySQL, and we'll take a look at other table modifiers. So a storage engine is something that you can specify as a table modifier, and then we're gonna see how we can use where clause and group by and having, and also user-defined variables. Okay, so let's move on to advanced field modifiers. Let me just hide this one. So these are the field modifiers you can use. Auto increment, we talked about this one last week as well. So this is typically is used for primary key column, and basically you are asking MySQL to automatically generate a number, and it will increment previous number by 1. Index is very important for performance reason. It basically indexes a field. So when a field is indexed, MySQL no longer has to scan the whole table. Instead, it's going to use index to locate the record. So performance reason is very important. Unique means the value has to be unique. So if you try to add a value, if you try to add another row that is duplicate previous duplicate with another row, then you are going to have an exception. Alright, so this is an example of auto increment. So here we create a table of employees, and employee ID we are setting with auto increment modifier, and employee ID is primary key. So here we are inserting 3 records. So we can actually manually provide the employee ID values. So these are the values that will be used. However, if you don't specify the value, in this case, it's going to be allocated by MySQL. Okay, so in this case, Angie will have a value 4, John's will have a value 5. This is index. So here, basically, we are creating employees, and here there is a field. There is a column called the department, and we are saying that we want to index the department column. And later on, when you are performing a query operation on department, it's going to be a lot faster because MySQL does not have to scan the whole table to meet that query operation. Instead, it's going to use index. Unique means that value has to be unique. So here we have a name field which has to be unique. So in this case, when you are adding the 2 rows that contains the same values, it will cause an error. So this insert operation, whole insert operation will fail. Alright, so let's do exercise 1. So I am going to go to here, and let me just move this one. Oops. Okay, so we're going to actually move on with the exercise 1. Exercise 1. First of all, you have to, so let's go to some setup. Let's actually see some setup you have to do. First of all, I assume you have studied MySQL D, database server. And then in this hands-on lab, you're going to actually exercise MySQL command in terms of a file. So we want to actually go to the hands-on labs, MySQL _ Basics II. And then we are going to read files from the samples as SQL samples directory. So I want you to go to this hands-on lab location, the location that you have unzipped, and then we are going to start MySQL shell, and you want to specify which database you want to use. So these are the three things that you want to actually do. All right, so now let's try the auto increment. So here, this is pretty much the same. So here, if you can actually see any help on these commands, you can just type help and name of the command. So that's something that we learned last week as well. So let's just try it. So it gives you help information, and you can actually go to this website. This is actually 5.5. I'm using 5.5. You can go to this website, and you can actually see detailed information about it. So let me just go here. Oops, I think let me just. Okay. All right, so it gives you detailed information of auto increment, okay, including some examples. Okay. All right. So let me go back here. So what we're going to do is we have a file called auto increment on primary key.sql file on the SQL the scripts directory of this hands-on lab, and this is basically what we have seen in the slide as well. So here we do auto increment, and then we have create 3 records specifying the ID ourselves, but here we are creating employees without specifying ID. In this case, MySQL will provide the ID value because we have used auto increment. Okay, so we're going to just execute this one. So I'm going to copy this way, source, and as expected, it displays employee table, and you can see the value is 4 and 5 automatically assigned by MySQL. Right, so this is what we have done. Okay, yeah, some troubleshooting. So if you are not, so this command, this location of this file, I'm using relative path. Okay, so that's the reason you have to actually start MySQL shell on the directory of this hands-on lab unzip directory. Okay, but you can specify the full path here if you want to. Okay, so if you receive failed to open the file, make sure that you're actually starting in the right directory. All right, another one is if you have not specified the database, default database, you are going to see this message, no database selected. Okay. All right, the next one is unique. So here again, this is the same same code that you have seen in the presentation. So we are going to try copy. And as expected, here we are trying to add duplicate row. So this name field is unique. And if you're trying to add the row that contains the duplicate name, then it will return duplicate entry, John's for key name, error condition, error 23,000. All right, the next one is index. So here we have specified we want to create the index for this department. Okay, so we have actually 2 unique fields. One is, of course, primary key. Primary key has to be unique, and we also specify that name column is also unique. Okay, and the department column is not unique. It doesn't have to be unique, but we want to create an index of it. So we say index and name of the column. Okay, so we created 3 test cases. Okay, so we have added Angie and Bobby and John's, okay, and their engineering department, their department, and then their salary, right? So what you're going to do is we're going to actually display the employees table. So we're going to actually see these 3 rows, right? Okay, and you can also show all the indexes from the table by saying show indexes from employees, okay, and also you can specify the show only primary keys. Okay, so let's actually run this guy. So we are going to copy this one. Okay, so let me just expand this one. So this is the table, okay? And this is a way that you can actually see the index information, okay? So these are the names of the keys. You can actually see and the sequence in index. And let's see what else here. So basically, it actually index type. So it's actually using p3 for its index type. And the last one is we are just displaying the primary key. I mean, we are just kind of displaying this information. Okay. Now, if you actually say describe employees table, you can see employee ID is primary key. So this is a key column. Okay. So when you say describe what disk name of the table, it gives you meta information of the column. So these are the columns field: employee ID, name, department, salary. So name is unique key and department is mul. What that means is that this is duplicate. It's not unique. It's non-unique index has been created. So when you say mul, when you see mul on the key, that means the non-duplicate column index has been created. Now salary has not indexed yet, so that's the reason you don't see anything on the key column. Okay. All right. Now on the 4, we are going to add index to existing tables. So what we have seen here is that we are actually creating a table indicating a particular field has to be indexed. Now, if you have a bunch of index tables and now you are performing some query operation, including some columns, and if those columns are not indexed, then you can actually add index constraints to those columns to have a better performance. So you can actually obviously see create index, and so you can see, this is the way that create. So let me just to show you. So let's see the employees, and this is what we have seen, right? So there is no keys. So let's do that one more time. So there is no key value for salary, which means the salary field has not been indexed. Department has been indexed, right? So we are going to create an index for salary. So this is the command. So what it does is that create index for salary on this table. Okay, so now if I display employees, now you can see salary is now indexed. Okay, so again, MUL stands for the non-duplicate the indexed column. Okay, you can drop the index information on a particular column. So in this case, we are going to drop indexing on the salary column. Okay, so here we're going to just drop it again. And now if you see description of this table, now you can see the key value is gone on salary column. All right, so let's move on. I'm going to take questions at the end of this presentation. All right, so next is the table modifiers. And so there are few table modifiers, and one important modifier is actually storage engine. And what is a storage engine? Storage engine is underlying software component a database management system uses for performing database operations. So basically, it's the implementation of the database underneath for representing a table. So each table is associated with a particular storage engine. Okay, a table could be created with a particular storage engine, or it could be altered to a different storage engine later. So storage engines, so MySQL support in fact the set of storage engines based on pluggable storage engine architecture. In fact, on MySQL 5.5, there are 9 storage engines, and we are going to see the list of those storage engines that are supported on a particular MySQL version. So each storage engine has its own advantages and disadvantages, and you might want to choose a particular storage engine to make sure that you get the right performance for your particular behavior of your database operations. Now, different storage engines can be assigned to different tables in a single database. So, single database could contain multiple tables. Each of those tables could have its own storage engine associated. Now, the factors to consider which storage engine you want to choose for a particular table includes these issues, like a frequency of reads versus writes. For example, MyISAM could be better choice if table access is mostly read, meaning select operations. Whether transaction support is needed or not. In fact, there is only one storage engine, InnoDB, that supports transactional behavior. Okay, so if you need a transactional behavior, then you have to use InnoDB, which is, by the way, is default. Indexing requirements could be different depending on the storage engine you are using, and OS portability and feature extensibility and changeability. So these are the factors that you might want to consider. So these are the set of storage engines that are supported in MySQL. Again, there are 9 storage engines that are supported in MySQL 5.5. So InnoDB is a default, and as I said, InnoDB supports transactional behavior, which means that InnoDB storage engine provide ACID properties. So ACID stands for the atomicity, and consistency, integrity, and durability. Okay? All right. So it supports transaction, which means that it supports commit, rollback, and crash recovery capabilities to protect user data. So one of the topics that we are going to cover in this course is, in fact, transaction, and we are going to play around with the commit, rollback, and things like that. Okay. MyISAM is based on all the ISAM code, but has very useful extensions, and there is also a collection of identical MyISAM tables that can be used as one. That's a merge MyISAM. And that are federated, the storage engine enables data located on remote MySQL database can be accessed as through the local server. Archive is used for storing large amounts of data without indexes in a very small footprint. So, if the small footprint is important, you might want to change it to archive. Okay. CSV stores data in text files using comma-separated values format, and black hole is really a black hole. It doesn't do anything. It just accepts the data and throws it away and does not store it. Okay. Could be used for testing purpose, maybe. And okay, so this is the same thing we have seen. The memory is hash-based, stored in memory, and useful for temporary tables. Okay. So in most cases, you are going to deal with InnoDB. Okay, so when you're creating a table, you can specify storage engine of choice of yours. So here, I'm creating a table indicating the engine I'd like to use is InnoDB, and here I'm using MyISAM. And if you create a table without specifying anything, then InnoDB is the default. All right, other miscellaneous table modifiers. Auto increment specifies the starting value of auto increment field. So you can actually specify auto increment at the table level in addition to the column level. And character set and collate specifies the table character set and collation. And checksum specifies whether table checksum should be computed and stored. And max rows and mini rows, you can specify maximum and minimum number of rows a table can have. Pack keys specifies whether index should be compressed or not. Again, if storage, the size of the table, including indexes, is important, you might want to pack keys. Delay key write specifies whether indexes should be updated only after all writes to the table are complete. So it might actually improve performance for tables with high frequency of writes. Okay, so for these kind of cases, and if the performance is important, you might want to actually choose delay key write. Data directory you can specify the default non-default data directory, and index directory also you can specify non-default index directory, meaning directory where index table gets created. All right, so let's do exercise 2. So this is the table modifiers. We're going to actually play around mostly storage engines. So if you say help storage engines, you can actually see detailed information here. So now if you want to display all the storage engines that are supported by a particular version you're using, so you can say show engines. By the way, \G means it's actually giving you a bit more structured information. Okay, so let's try without \G. Yeah, so it gives you kind of table format, yeah. So this is in fact the much easier to read. So here you can see it says support and comment, but if I want to see a bit more detailed information, you can actually say storage engines and \G. And now you can see each storage engine has, this is the name of the engine, whether this is in fact supported at this point or not, and comment. And so then you can see whether transaction is supported and distribute transaction is supported, or also save points is supported. So you can see transaction support is only allowed in InnoDB. So here, so InnoDB is the only one that has transactions support. Okay, so mostly you're going to actually work with InnoDB when you're using MySQL. All right, now this is a case that we are creating a table with InnoDB explicitly specifying the engine attribute value. So let's try this one. Oops. Okay, so let's copy it up. My keys not worked out well. Okay. Oh, okay. So T1 DB is already existed. So let me just drop table and T1 DB. And if I run this one again, okay. So you should actually create InnoDB, and let's see whether I have. So let's see whether I have created these tables already. So show tables. Okay, so it looks like I have created already. So if I actually see show table status, okay, so you can see this is InnoDB, and this is my ISAM, and this is again InnoDB. So this table is T3 default. So if I don't specify storage engine, then it will use InnoDB as a default. Okay. All right. So that is that. Yeah. So this one, select engine from information schema table. So information schema table is a meta tables for MySQL. So in here you can actually see the engine column. So if I say select star from information underscore schema table, and if I do, and I see a bunch of meta information. So here, I just want to actually see table schema is for my DB, and the table name is this InnoDB. So this is the case that I'm just trying to display only the only the engine storage engine information of this particular table. Okay. Later on, we're going to actually learn how to use a PHP MyAdmin GUI tool. So this GUI tool PHP MyAdmin also let you see the type of your tables, of course. Okay, so let's move on to the next one. Next one is where clause. So I'm sure if you have worked with SQL or JDBC, you probably know how to use where clause. So where clause provides a condition for query operation. So here, basically what I'm saying is that I like to, from employees table, I like to display all the rows and their columns whose salary column is greater than 3,500. And logical operators are also allowed in where clause. So here, logical operator, this one or this one. Okay. Now this condition we are using and not. So here, department ID is 1 and the name cannot be Nicole. Okay. So this is the and or not operators being used. Between, so I like to get all the rows and their columns whose salary is between 2,000 and 4,000. In means that name has to be in one of these two in this case. Like is a pattern, so here I like to get all the employees whose name it contains character N in the middle, okay, or at the end. So this % sign is a pattern. So this one is, I like to get all the employees whose name ends with E. Okay. You can also use the regular expression by using regular expression keyword here. So here we are using very simple regular expression, either John's or Mary. And here, this notation means starting with. So I'd like to get all the employees whose names start with J. And here, $sign means that ends with. So I'd like to get all the employees whose name ends with E. Okay, so all the regular expressions, here we are using very simple regular expressions, but more complex and complicated regular expressions are supported. Distinct means that I'd like to get distinct rows of salary, meaning salary, even though there are some duplicates, I want to actually get only the distinct values of salary column. So I'd like to see what is the distinct list of salaries from employees table. Relatively straightforward. Okay, so let's do exercise 3. So here we are going to compare operators. So here we are creating a table of employees, and we have added 5 employees. And their salary range from 3,000, 2,500, 4,000, 5,000, and 5,000, right? So here, salary is greater than 35. So we should actually see 3 employees, right? So that is the comparison operator.sql file. So I'm going to just copy this one, and this one you can see 3 of them, okay, as expected. And this one is and or. So again, this is something that we have seen in the slide. So I'm going to just execute it. All right, so you can see we have 3 rows that actually meet the need. Okay. So here, so we have a two-where clause. So this is the case that salary is greater than 35 and department ID is greater than 2. So we have 2 entries. And this one is and or operation, so we have 3 rows that meet this where condition. Using between, so we're basically displaying all the employees who's making between 2,000 and 4,000. Okay, so let's try this. All right, so we have 3 employees that meet the need. In means we are displaying all the employees whose name is either Nicole or Jack, meaning the name has to be in one of these 2. Okay, so we have both. So we are going to see 2 employees. Okay, and order by is actually the result is going to be in order. So as a default, it's going to be ascending order. But if you want to have descending order, you can specify the descending order based on name. Okay. So let's actually display order. Okay, so here his name is ordered ascending, and this is descending. Okay, and this is like. So this is the case we have seen in the slide. So if I run this, all right. So that's like. And this is a regular expression. So here I'm going to use regular expression. Again, this is the same code that you have seen in the slide. So okay, so this one ends E, and this one start with a J. Okay, and this one is either Mary or John's, right? So either Mary or John's. Okay, and the last one is distinct. So here we are going to specify distinct SQL here. Okay, so we see distinct entries of salary. So if you exceed the salary, the salary has one duplication. So here 5,000, right? So we are going to see 3,000, 2,500, 2,500, 4,000, and 5,000. Okay, so last one is we saw like regular expression and distinct and limit. Limit is I like to see the result on this limit. Okay, so if there are 4 rows that meet the condition, but I want just to see the first 3. So here, let's try this. Okay, so we're going to see just 3. All right, so that is where clause. Again, this is nothing really unique in MySQL, so you probably have seen, where clause in many different places. Next one is group by and having. Again, this is SQL, the keywords. Okay, so group by returns a group of rows, and it basically divides a table into sets, and typically it's going to be used with aggregate functions such as a count. And it basically produces a summary value for each set in this case. So let's see the example. So let's say we created a table of employees. Okay, so we have 5 rows, right? Okay. Now what we want to do is we want to display how many and in each of these row has a department ID here, right? And we'd like to see how many employees per each department. So in this case, what you can say is that select department ID, and then you're going to use the aggregate function of count based on employee ID. Okay, and so you are basically getting the count on employee ID. How many employees are in fact belong to a same department ID, and then we are gonna group by department ID. So what it means is that we want to group based on department ID. So that's what you're going to see on the left because we specified department ID. And we also actually want to see the number of employees that belong to that department ID. So this is basically, the way that you are going to use a group by. So group by is basically creating groups, okay, based on the particular field. Having is like a where for groups. So, just like where clause limit rows, having clause limit groups. Okay? So in most programming exercises, you are going to use having with group by. So let's say an example. So this is the same example. So this is the same code that you have seen, right? Now here, what we want to see is that we want to actually see only the groups whose employee count is greater than 2. So in our previous example, we have seen there are 3 departments, and each department have employee count 221, right? But we want to actually display only the group department IDs whose employee count is greater than or equal to 2. So we only limit just these 2. Okay, so that's where you are going to use having. Having employee count is greater than 2. So employee count is basically this. We are using alias. Okay, so count employee ID as employee count. So once you set the alias, then you can use this alias. All right, so let's do exercise 4. Again, this is exactly the same code that we have seen in the slide. So let's try to run source group by. Okay, so we have seen 3 departments with employee counts for each of those departments. And having is, basically we have a having clause. So we are going to use having.sql file, and we are going to see just 2. Okay. All right. Let's move on to the last topic. User-defined variables. So I'm not sure how many of you, in fact, are aware that you can have variables in SQL. Okay? And basically, you can store a value in a user-defined variable in one statement, then you can actually refer to that variable later on in another statement. So it works like exactly a variable in other programming languages. However, these user-defined variables are connection-specific, meaning two different users cannot share, cannot share a variable. Okay? So all variables for a given client connections are automatically freed when the client exists. So, I'm actually running as one single client, MySQL, right? If you run another one, whatever variables that I define here cannot be shared with another user. So it's only per connection specific. So the way that you can define a variable in MySQL is like a name of the variable. And then the way that you can set value to that variable is either, there are two different ways. You can use set command, or you can use select and the value into name of the variable. Okay. So here you can actually have some expression, and you can have a multiple variable definitions like this. Okay. By the way, for set command, you can use either equal or colon equal, the operators. All right, so these are the examples. So here I am defining my var1 variable with a value 10, and here I'm defining my var2 with a value 20. Okay, so again, you can use either equal or colon equal notation. And then I'm displaying those values. So here I'm displaying my var1, which is 10 here, okay, and my var2, which is 20, and then I'm actually computing another variable with my var1 and my var2. I'm adding those two to create my var3. So you can see these are the values that are being displayed. Okay, here, let's see. Here I'm actually creating another variable. This is the string variable. So I'm actually assigning Sang Shin to my string var. And then I can actually call upper method and upper function and lower function on those variables. And you're going to actually see like this, capitalized uppercase name of me and the lowercase of me. All right, now here you can also use select into notation here. So I'm basically setting my var4 with value 67. Okay, so this is exactly the same as set at my var and 67 equals 67. And here I'm actually getting the value from my var4, which I have defined right here, and then add 10 to it, and then I am assigning to my var5. Okay, so if I display my var4 and my var5, then you're going to see 67 and 77. All right, so our last exercise. So this is pretty much what we covered in the hands-on lab. Okay, so we're going to just try this. Okay, so let's try. So here I'm setting my var1 and my var2 with a 10 and 20, and then I'm going to display my var1 and my var3, and you can see 10, 20, and 30. Okay, and you can certainly change this one with providing some the alias. So here I'm basically using alias result. So if I try this, I'm using alias result, then you're going to see result as a column name. Okay, and this is a case that I'm assigning a value, string value, to a variable, and then I'm going to change the value to uppercase and lowercase in display. Okay, so as expected, it's uppercase value and lowercase value. And here we are using select into. So here we are going to set 67 to my var4, and again I'm going to display my var4 here, and it should display 67. And here we are setting the value of my var5 using the value of my var4 and add 10 to it. So it's done. Now if I display, it will display 67 and 77. Alright, so that's pretty much it. The homework is basically creating the SQL file in which you're going to create a database called MyOwnDB, and then you're going to create your own table called my own students, and that should contain these fields. And then you're going to use field modifier and table modifiers. So table modifier, you're going to use name field. You're going to use the field modifier to make sure that name field is unique and school field is indexed. Okay, and then you're going to add 7 example records, and then we're going to use the user-defined variables like this, and you're going to use compute them from the records and display them. And yeah, so that's pretty straightforward homework. All right, so that is all I have. So let me